So we're now going to move on to the last unit of the year, and that's going to be our statistics and probability. And we're now going to first start going over by our outcomes and our probability. So at the end of this video, our learning objectives is you're going to be able to identify all the possible outcomes, or sometimes we might talk about them as events instead, but the outcomes or events of an experiment. So you're going to know how to identify all the possible outcomes. You're going to know how to list what's called a favorable outcome of an event, and then you're going to know how to calculate the probability of an outcome or an event happening. So we're going to learn how to identify our outcomes, list our favorable outcomes, and then calculate the probability for it. So that's what your goal is to be able to do by the end of this video. So first, let's start talking about, well, what are outcomes? So now we're going to talk about experiment, outcomes, events, and all of that. So what is an experiment? An experiment is an investigation or a procedure that has varying results. So rather than talking about the marbles down below, let's talk about something else as well, so we can see about it and hear about it in two different ways. So if we decide that we have six people and we want to determine the order that we're going to go, and people are going to present, I can have a six-sided die and I can give a number to each person. Well, in this case, rolling the die itself would be the experiment or the investigation, because it has the varying results. It can be a 1, 2, 3, 4, 5, or 6. So the idea of picking the die to represent the different people and roll it, that would be our experiment. The possible results of an experiment are called the outcomes. So back to the rolling of the die, we have six different outcomes that we can have. We have the 1, 2, 3, 4, 5, or 6. So those are all an outcome. And then a collection of one or more outcomes is an event. So in this case, if we are now just saying, okay, we're going to focus on just the number two, and that's the one that we're trying to talk about here, like that would be our event. Our event is that number two occurred. The outcome of a specific event is called a favorable outcome. So going back, if I said, okay, we want to roll a number two, and we actually roll the number two, that's our favorable outcome. That's what occurred. That's what we wanted to happen. So it's the actual event that we are going to discuss or look at, or that takes place. All right. So it's kind of like what we are hoping to happen. When we go through the marbles, we'll explain this in just one more example. All right. So those are the things that you have to understand. You have to understand that when we talk about experiment, it means that we're actually doing something, and going to be looking at the different results that are happening. And then when we talk about the possible results that could happen, those are our different outcomes. And then when we are actually performing the event, or I'm sorry, when we're actually performing the experiment and something happens, that's our event. And then when we talk about a favorable outcome, that's what actually took place. That's the specific event that occurred. And when we get to probability, it's going to be talked about as the specific event of what we want to happen. All right. So now let's talk about in terms of the marble. So if we're selecting random marbles from a bag, well, that is an experiment. We're putting the marbles in a bag and we are grabbing them at random. So our experiment is seeing which marble we're going to pull out of a bag. Each marble in this is its own outcome. And then if we say, okay, we want to select a green marble from here, now we're talking about a specific, or not we want to, but we do select a green marble. That is our event. The event that took place was we selected these two green marbles. And those will be considered our favorable outcomes, because that is what we were looking to happen. That's what we were wanting to happen. And that is what did happen. So it's our favorable outcomes. So when we think about favorable outcomes, we're talking about a specific example. So if I want the blue to happen, well, picking a blue out would be our favorable outcome. It's what we are looking to occur, what we are testing, or what we are wanting. And that could change. I can pick out of the bag 10 different times, and 10 different times I can pick out a blue, that's my favorable outcome. Pick out a purple, that's my favorable outcome. Pick out a yellow, that's my favorable outcome. So it's what's actually taking place. And a lot of times when we talk about this in class, we're going to say, well, what would happen if this takes place? So our favorable outcome is also something that we are looking to happen at times as well. All right, let's go through a couple examples of being able to list our outcomes, discuss our favorable outcomes before we get into probability. All right, so we're going to go through and identifying all the different things that we can here. So it says identifying outcomes. You roll the number cube. So we have a six-sided die here, and we're rolling this. All right. What are all of our possible outcomes? So first off, the rolling of the dice is our experiment. So we're trying to see, well, what are we doing when we roll this? What numbers are we going to get? And our possible outcomes are all the different numbers. So our possible outcomes are 1, 2, 3, 4, 5, and 6. It's what we can actually get when we roll the die. So when we roll this, we can't get a 7, we can't get an 8, we can only get a 1 through 6. So those are all of our possible outcomes that we can have. Right now it says, what are the favorable outcomes of rolling an even number? So when we say favorable outcomes, that means like if we go into this and we're performing an experiment and we only want this to happen, that's what we're hoping for, or we roll it and it does give us an even number. Well, what were the possible things that if we're saying we want to roll an even number, what are the ways that we can win this? So if you imagine this as a game and you're rolling the die against your friend and you say, okay, every time I roll an even number, I win. Every time I roll an odd number, you win. So the favorable outcomes for me is when I win. So what are all the chances, or what are all the numbers that I can win on? And that would be 2, 4, and 6. Any even number on this die, I would win. So that is a favorable outcome for me. Where the non-favorable outcomes would be the 1, 3, and 5, because that is when my friend would win. So you can think about it and chant in that as well, as if our favorable outcomes, if this is actually a game where you can win or lose, well, how can you win? What would you do in order to win? And if we want to roll an even number, our favorable outcomes would be any of the even numbers, 2, 4, or 6. All right, so that's the way you can think about it as well. So for the next question, it says, what are the favorable outcomes of rolling a number greater than 5? So once again, you might be playing your friend and you might have won and rolled a whole bunch of evens in a row and you keep winning. So you say, okay, let's make this so you can win once. I'll do anything greater than 5, I win. Anything 5 or less, you win then. So what are your favorable outcomes of winning? Well, you only have one chance of winning this time, and that is a 6. And that means 1, 2, 3, 4, and 5 would be the non-favorable outcomes where your friend would win. Right? And being able to identify these favorable outcomes is really, really important for the next step that we're going to learn in just a few moments, which is our probability. We have to be able to identify, well, what are the events that allow us to win, or what are the outcomes that allow us to win in order for us to calculate our probability. All right, so there's one other kind of question we need to go through with these outcomes, because it's not just the being able to identify and list them like we did in the last one. Is when we're getting into our next part of this, which is probability, we are dealing with how many we can do, and you have to be able to identify the difference between when we say what are or list them versus how many. So for these questions, if you notice, they all say how many. So our answers will be a numerical value. And that's what we need to be able to do, more so than just counting or being able to list them. We need to know how many, because when we're dealing with probability, we're going to be dealing with fractions, and we're going to be dealing with division and percentages. So we need to know how many of the events can occur versus just listing them. So we need to be able to do it in both ways. So for this one, when we see how many, that means that it's asking a numerical question. So we're just going to be answering this in a numerical value. So we spin the spinner. How many possible outcomes are there? Even though we see 3 different reds, they're their own space on the spinner. So we have 1, 2, 3, 4, 5. We have 6 different outcomes. So how many possible outcomes are there? There are 6 different ways that the spinner can be spun. So there are 6 outcomes. Even though we have multiple red, they are still their own unique space on that spinner. So we would count them as an individual outcome. And how many ways can the spinning red occur? So same thing, even though we might think, oh, well, that's red, so it's all one, but there are 3 different spaces on this spinner. So red can occur in 1, 2, and 3 different ways. So there are 3 different ways that we can spin a red spot on this spinner. So our how many answer would be 3. So you see, we're not listing anything on here. We're just simply counting, because the question in this one is asking how many versus list or what are the possible outcomes. In how many ways can spinning not purple occur? So in how many ways can spinning not purple occur? Well, if this is our only purple space, well, then we have 1, 2, 3, 4, 5 different ways that non-purple can occur. So 5 different ways. So this question said how many. Now the second part of this question says what are. So you see there's a difference between how many and what are. For this one, we're simply just saying the number. Simply just saying how many. Well, what's the number? And what are, we actually need to list them. So we have red, red, red. Then we have green and blue. So you see there's a difference between when we say how many versus when we say what are. When we say what are, you actually need to list them. When we say how many, you just simply need to count them. All right, so now from here, we're going to move on to probability. All right, so probability. Well, what is probability? Probability of an event is a number that measures the likelihood of an event will occur. So it's saying, well, what are the odds that this event will happen, or what is the likelihood that it will happen? And probabilities will range between 0 and 1, or you can think about it as 0% to 100%. And and we can include 0 and 1. And when we are at 0 or 0%, it is impossible for it to happen. It means it cannot and will not happen. If it is 100%, that means it is certain to happen or it will definitely happen. And then 50% is equally likely to happen or not happen. So think about when you flip a coin, you can either get a heads or a tails. Each of those on every single coin flip is this a 50% chance of happening. We have an equal chance of getting a tails as we do a heads. So it's 50-50 right in the middle. And then as we move closer to 100% or 1 from that 0.5 or 50%, it becomes more and more likely that it will happen. And when we get to that 3/4, 75%, then we would say it is likely that this will happen because it's a pretty significant event of it, and it's about halfway between that 50 and 100. So we would say that it's more likely to occur. And as we get closer and closer to that 0, we're saying it's more unlikely that it will occur. Same thing, 25% is where it kind of crosses that threshold where we can say, okay, now it's unlikely that it's going to occur. But the closer it is to 50%, the more that it's still like in the middle, and it could be leaning one side, but still the other side, like it could be close to the other one happening as well. But as we get closer and closer to that 100%, it becomes more and more certain to happen. Or as we get closer and closer to that 0%, it becomes more and more unlikely or more impossible for it to happen. All right, but it cannot be an event. The probability of event cannot be more than 100%. So, like when someone says, "Oh, I'm giving 110% effort today," that just doesn't really make sense if you're actually thinking about it in terms of math. But the probability will range from 0 to 1, or 0% to 100%. Dead smack in the middle, it's equally likely to happen or not happen. And then as we move closer and closer to 1 or 100%, it becomes more and more likely. And as we move closer and closer to 0 or 0%, it becomes more unlikely for it to happen. All right, so you just have to just be able to identify that if something is 80% of a probability, then we would say, yeah, there's a really good chance and it's likely that it will happen. It doesn't mean it definitely will, because there's still a 20% chance that it won't, and that could still happen. But we could say that, yeah, this event is likely to take place. Whereas if it's a 55% chance of happening, it's really close to in the middle. So we would say, it's leaning towards happening, but not by much. All right, so let's go ahead and calculate and talk about how we can calculate the probability. All right, so when we're actually calculating the probability of an event, what we are doing is we need to list all of our favorable outcomes, the number of favorable outcomes, not list, I'm sorry. We need to put the number of favorable outcomes over the number of possible outcomes that we have. And you're going to hear me talk about this as what we want to occur over what can occur. So let's just think about rolling a die. Well, we have 1, 2, 3, 4, 5, 6 different possible events that could happen. So if we want to find what is the probability of rolling an odd number, we would write the probability of odd. So we put inside that parentheses what we're looking to happen. So see how it says the event. So we put inside the parentheses of what we want to happen. And then we say, okay, if we want to roll an odd number, well, our favorable outcomes or what we want to happen, what we're looking for is a 1, 3, or 5. So we have 3 different outcomes that can occur. And those are the number of favorable outcomes that we have. And then we say, okay, well, what are all the possible outcomes, the number of possible outcomes that we have for rolling a dice in general? And there are 6 different outcomes that we can get. So it becomes 3 over 6, or the probability of rolling an odd is equal to 1/2, which is equal to 0.5, or 50%. So going back to that chart that we have, this is equally likely or equally unlikely. It's right dead smack in the middle of what can happen. So we actually can't talk about this if it's a favor, like if this is likely to happen. We would say that it's right in the middle. We have an equal chance of getting the odd numbers as we do of don't getting the odd numbers. All right. So that's how we calculate the probability. It's what we want to happen or the number of favorable outcomes over what can happen. All right, so let's go ahead and do a couple more problems with this. And as we do this, we'll also talk about whether or not the event is likely to occur or not likely to occur. All right, so we have these 8 marbles and we place them in a bag and we randomly select a marble. What is the probability that you randomly select a blue marble from the bag and describe if it is likely to occur. So first thing, we know that our probability of blue, that's how we would write this, is equal to, well, how many times can we select a blue marble? We have two blue marbles. So the number of our favorable outcomes, or the number of events that we want to take place, is 2. And then how many marbles do we have in general? Well, we have 8 marbles here. So it'll be 2/8. When we're dealing with probability, we always write this as a decimal or a percent. And 2/8 can be written as 0.25 or 25%. So the odds of us picking a blue marble from random out of this bag is 25%. And is it likely to occur? No, this is pretty low. It's halfway between that 50% and 0. So we would say that this is unlikely to occur. Doesn't mean that it can't. It's unlikely to occur because there's only a 25% chance. All right. Now it says, what are the odds or probability of you randomly selecting a yellow marble? So the probability of yellow. Well, how many yellow marbles do we have? Well, we have 3 yellow marbles. So that means that we have 3 favorable outcomes that can happen, or 3 things that we want to take place over the 8 total marbles still. And 3 divided by 8 will give me a 0.375 or 37.5%. So this is now halfway in between that 25 and 50%. So it's still unlikely to occur, but not as unlikely as our blue marble. So I would say maybe somewhat unlikely. That it's pretty close to 50-50, but not quite there. And it's still leaning towards a side of not happening. So I would say it's somewhat likely to occur, somewhat unlikely to occur. All right, and then the last one, which should be letter C, actually, not B. But what is the probability you choose a green marble? So the probability of green, well, in this case, we only have a 1 green marble there. So our only favorable outcome that we have is 1. 1 divided by 8 is 0.125 or a 12.5%. So what is the probability of this happening? I would say this is very unlikely to occur. Doesn't mean that it can't, but it's very unlikely because there's only a 12% chance of you getting that, which is really, really close to 0, which we know 0 means it is impossible. And it's much closer to 0 than it is to 50 or 100%. So I would say it's very unlikely to occur. All right, there's one more example that we're going to go through in here, and then that will be it for this video. All right, so it says the probability that you randomly draw a short straw from a group of 40 straws is 3 out of 20. How many are short straws? So this is not taking into what we learned before with proportions. So we know that this ratio or this probability is representing our favorable outcomes over total. So this 3 out of 20, we know, is saying how many favorable short straws there are versus how many total straws. So they tell us the total number of straws that we have, but we don't know the total number of short straws. So we can create another ratio where we now are looking at it in terms of total. This was reduced. And now this is going to be our total. Well, we don't know how many total short straws there are, so we can represent it by X. So we can say that the ratio of simplified is 3 out of 20. That's the same thing that we are talking about and that we've done before. So we can then look at it in terms of the total number that we have, and we just had to be consistent with our ratio. And once we do this, because we have our short straws in our numerator in both cases, and we have the total outcomes in our denominator in both cases. So then we can just go ahead and cross multiply and get 20x is equal to, well, 3 times 40. So then we get 20x is, I'm going to write it up here because I'm running out of space. So 20x is equal to 120. Divide by 20. X is then equal to 6. So that means that we have a total of 6 short straws. All right, so it's just showing you that we can use things that we learned previously with proportions and ratios to help us solve this problem as well. And there's other ways you can go about doing this, but you would need to show me your work regardless. All right, now that is it for this video.